Hey everyone, welcome back to Bugnojutsu. In today's video, we're going to break down an interesting problem from LeetCode 1733, minimum number of people to teach. This problem is a great mix of graph reasoning and set operations, and it really pushes you to think carefully about optimizing what looks like a brute force solution at first glance. By the end of this video, you'll have a crystal clear understanding of how to solve it efficiently, and hopefully you'll pick up some insights that will help you in similar graph and greedy style problems. So let's start with the problem itself. We're given a social network with multiple users. Each user can speak one or more languages, and friendships exist between certain pairs of users. Two users can communicate only if they have at least one common language. If they don't share any common language, then there's a communication gap. The task is, we are allowed to choose one language and teach it to some users. The goal is to teach the minimum number of users such that all friendships become valid, meaning every friendship pair is able to communicate with each other. It's important to note here that friendships are not transitive. For example, if user A is a friend of user B, and user B is a friend of user C, that does not mean user A and user C are considered friends. Each friendship is only between the two directly mentioned users. So, in simpler words, we need to fix the communication gaps by teaching one language to the smallest number of people possible. Let's walk through an example to make it more concrete. Suppose we have n equals 2, meaning there are two possible languages in total. The languages array looks like this. User 1 knows language 1. User 2 knows language 2. User 3 knows both languages 1, 2. Now the friendships are given as 1, 2, 1, 3, 2, 3. Let's analyze. Between user 1 and user 2, they don't share any common language. So they cannot communicate. This is a problematic friendship. Between user 1 and user 3, they both share language 1. So this friendship is fine. Between user 2 and user 3, they both share language 2. So this is also fine. So the only problematic edge here is between user 1 and user 2. To fix this, we have two possible strategies. Teach user 1 language 2, so they both know 1, 2, and can now communicate with user 2. Or, teach user 2 language 1, so they both know 1, 2, and can now communicate with user 1. In either case, we only need to teach one user. So the answer for this example is 1. Now let's dive into how to solve this problem step by step using the method I followed. First, I created a mapping of each user to the set of languages they already know. Storing this in a set helps a lot because checking for overlaps or common elements becomes efficient. Next, I iterated over all the friendships. For each friendship, U, V, I checked whether the two users had any common language. If they didn't, then this pair is a communication gap. In that case, both users are considered problematic users, meaning they're candidates who might need to learn a new language. Once I had this set of problematic users, the key was to minimize the teaching. The idea is simple. Since we can only teach one language, we need to figure out which language would reduce the number of teachings the most. So, for each possible language, I counted how many of the problematic users already knew that language. The ones who already know it don't need to be taught. The remaining ones would need to learn it. Finally, I took the minimum over all languages. This gives the smallest number of users we'd need to teach so that all friendships are valid. Now, let's talk about complexity. Building the user-to-language mapping takes about m times k, where m is the number of users and k is the average number of languages each user knows. Checking all friendships takes f times k, where f is the number of friendships. This is because we might need to compare sets of languages. Finally, for each language, we scan through the problematic users. That's n times p, where n is the number of languages and p is the number of problematic users. Overall, the algorithm runs efficiently within the given constraints. Space-wise, we're storing the mapping of users to sets of languages, which is also m times k. The main insight here is that you don't need to worry about all users, only the ones involved in problematic friendships. This drastically reduces the number of people you need to check. Another big insight is that instead of teaching different languages to different people, you just need to pick one common language and stick to it, because the problem allows teaching only one language. This is also a great reminder that sometimes brute force-looking solutions can be simplified by narrowing down the focus. By cutting the problem down to problematic users only, you make the problem much more manageable. And that's the complete breakdown of LeetCode 1733, minimum number of people to teach. Party popper. We covered the problem setup, worked through an example, understood the approach step by step, analyzed the complexity, and picked up some key insights. If you found this explanation helpful, don't forget to drop a like, share this video with your friends, and subscribe to Bugnojutsu for more LeetCode breakdowns and problem-solving insights. I upload regularly, and the goal here is to make every problem feel approachable and intuitive. Thanks for watching, and I'll see you in the next one.